Hello students, let's solve one more problem on finding Fourier series. Obtain the Fourier series of the function f of x equals to mod x in minus pi less than or equals to x less than or equals to pi, and hence deduce that 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on, that is equals to pi square by 8. That means here this question contains two parts. One is to find Fourier series for the function mod x. Another part is, after finding Fourier series, we need to deduce that obtained Fourier series to this form. Okay, this we'll see later. First let us find Fourier series for mod x. F of x equals to mod x pi less than or equals to x less than or equals to pi. That means here mod x, f of x defined in the interval minus pi comma pi. F of x equals to mod x. Mod x means, the definition of mod x means that mod contains positive and negative integers, both positive and negative integers. Therefore this mod x we can write it as f of x equals to minus x plus x. Minus x, this minus x defined in the interval minus pi to 0, and plus x, it is defined in the interval 0 to pi. The Fourier series of f of x having period 2 pi is given by f of x equals to a naught by 2 plus summation n equals to 1 to infinity a n cos n x summation n equals to 1 to infinity p n sin x. Let us take it as equation 1. Okay. Now we need to check the nature of the given function. We shall check f of x equals to mod x for even or odd nature. F of minus x equals to, since you know that the interval is minus pi comma pi, we will check the even and odd nature of a given function by substituting x equals to minus x in the given function. Okay, f of minus x equals to mod of minus x, and mod of minus x is nothing but mod x only by the definition. By the definition, this you can write it as mod x, that is equals to given function. Therefore f of minus x equals to f of x, and hence f of x is even function. Since f of x is an even function, the Fourier coefficient bn becomes 0. Therefore a0, now we need to find the a0 and the values of a0 and an. Okay, we know that a0 is equals to 2 by pi integration 0 to pi f of x dx, and an is equals to 2 by pi integration 0 to pi f of x cos n x dx. Okay, since you can see here the limits are 0 to pi. Okay, 0 to pi means the interval is 0 to 0 comma pi. Okay, in the interval 0 comma pi, the required f of x is nothing but plus x. Therefore by taking plus x as a required function, we will find the values of a0 and an. a0 is equals to 2 by pi integration 0 to pi x into dx. 2 by pi into integration of x is x square by 2, 0 to pi. Next is 2 get cancels. Substituting limits for x square, that is pi square minus 0. 1 by pi into bracket pi square minus 0, that is pi square by pi. Here pi 1 pi get cancelled. We are left with 1 pi, that is nothing but the value of a0. Therefore a0 is equal to pi. Now an is equals to 2 by pi integration 0 to pi f of x into cos n x dx. That is 2 by pi integration 0 to pi x into cos n x dx. Okay. Since you can see here x into cos n x is a product, applying rule for integration. An is equals to 2 by pi x into sin n x by n, that is x into u into integration of v term, that is x into integration of cos n x is sin n x by n minus u dash. U dash means derivative of this x, that is 1 into, here sin x by n is there, no, 1 by n keeping as it is, finding integration of sin n x, that is minus cos n x by n, and already 1 n is there, that n into n becomes n square, 0 to pi. Next 2 by pi into bracket, here you can see sin n x by n. If you substitute x equals to n here, that is sin pi. If you substitute x equals to 0, sin 0. And since sin n pi and sin 0 are 0, therefore the whole first term becomes 0. We are left with only second term. Minus into minus plus cos nx by n square 0 to pi. That is 2 pi into bracket cos n square 0 to pi. Next, substituting the limits, 2 by pi n square into bracket cos n pi minus cos n into 0. Cos n pi is minus 1 raised to n. Cos n into 0 is cos 0. Cos 0 is 1. Therefore, 2 by pi n square into bracket n minus 1. Taking minus 1 common from this bracket, we have an is equals to minus 2 by pi n square into bracket 1 minus of minus 1 raised to n. Therefore, we have the values a0 is equals to pi, an is equals to minus 2 by pi n square into bracket 1 minus of minus 1 raised to n, and bn is equals to 0. Substituting these values in the equation, we will get the Fourier series. Thus, the required series becomes f of x equals to a0 is pi, that is pi by 2, plus summation n equals to 1 to infinity an is minus 2 by pi n square into bracket 1 minus of minus 1 raised to n cos nx, bn is 0. Therefore, f of x equals to pi by 2 minus this minus summation n equals to 1 to infinity 2 by pi n square into bracket 1 minus of minus 1 raised to n cos nx. This is the one part of the solution, that is, this is our required Fourier series. Now we need to reduce this series to the whatever they ask, that form we need to reduce. Okay. To reduce the series, let us put x equals to 0 in the Fourier series. To reduce the series, let us put x equals to 0 in the Fourier series. That is, f of 0 equals to pi by 2 minus, taking this 2 by pi outside this summation, 2 by pi into summation n equals to 1 to infinity 1 by n square 1 minus of minus 1 raised to n cos n into 0. F of 0 is 0, that is equals to pi by 2 minus 2 by pi summation 1 to infinity 1 by n square 1 minus of minus 1 raised to n into 1, because cos 0 is 1. Taking this pi by 2 to LHS, minus pi by 2 is equals to minus 2 by pi summation 1 to infinity 1 by n square into bracket 1 minus of minus 1 raised to n. Taking this minus pi by 2 to, here you can see it is multiplication. If it comes to LHS, this becomes pi by 2 into pi by 2, that is pi square by 2, pi square by 4, summation 1 to infinity 1 by n square into bracket 1 minus of minus 1 raised to n. Now we need to find the value of this bracket term, 1 minus of minus 1 raised to n. The value of this term becomes 0 if n is even. The value of this term becomes 2 if n is odd. Right? If n is equals to odd, the value of this term becomes 2. If n is even, the value of this term becomes 0. Hence we get pi square by 4 is equal to summation n equals 135 to infinity 1 by n square into 2, or 2 into substituting n equals to odd numbers, right? 1 by 1 square plus 1 by 2 into 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus so on. Taking 2 to again to LHS, that is pi square by 4 into 2 is equals to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. That is equals to pi square by 8 equals to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. This is the required solution.